Hello, dear viewers. The time has finally come to talk about something interesting. The previous videos served as a bit of a preparation to talk about more advanced concepts. And today I'm going to discuss with you what is the VMware snapshot, how does it work, the concepts, principles, and actual background technology that happens. So after watching this video, you should know and understand what's happening when you take a snapshot, delete a snapshot, and revert a snapshot. And you should also find out what are the possible consequences of your actions and how to do this properly. So let's start with the outtakes. I'm going to quickly summarize what the video is about, and then I'll expand on it. So, what is a snapshot? A snapshot is a restore point you can create for the virtual machine, which means that you can later go back and restore the machine to the previous state. What's even better, it is not a linear restore point. So you can make a tree of snapshots, which means that you can go back and make another timeline. Think of it as a time travel point in time. So you create or you mark a state of the machine, you work on it, and then if something is wrong, you can go back. You can also snapshot it again, go back and make another snapshot. So you could now split the timelines. This is like the butterfly effect, but you have full control over it. It's very useful if you test different scenarios of installation or if you want to troubleshoot setup of components in different environments on the same machine. So you could redeploy if you need some kind of applications, and if you find that the applications don't act as you want, or if the result is wrong, you can go back and try it again the different way. So this is a very useful tool to time travel. Also, another outtake is that a snapshot is not something unspecific. A snapshot is a snapshot of your virtual disk drives. So the snapshot contains information about your virtual disk state, all the files in file system condition, and you can also snapshot RAM memory if you want to. But typically, you are snapshotting your virtual disks. And finally, the snapshot is not a true backup. A snapshot is a useful tool to do some maintenance or troubleshooting. However, there are two important facts. One, you should not leave your machine running on a snapshot for a very long time. There's even a VMware KB which states that it shouldn't be more than 72 hours, but I'm sure you can keep it much longer if you want to just make sure it's not a permanent situation. It's better if the machine is actually running on the base disks for many reasons. And second, it is not a true backup because if you lose your previous state of the machine, if you damage your machine files, you cannot go back because the snapshot depends on the old data that you had. So it is reliable to test in guest operations, but it is not reliable to preserve the machine itself, since you can still corrupt and lose data. And one more thing is that if you have snapshots and you don't have external backups, there's also a chance that some other user may touch your snapshot tree and you will be unable to restore if it does it wrong. So let's take a snapshot of the Windows machine we have created in the previous videos. The machine is on the left and I have a few options to take the snapshot. I can click a small icon which is located next to the Actions button, this icon, and this will bring up the snapshot action. You can also click on the Actions drop-down menu and select Snapshots, take snapshot from here. You can also right-click the machine, and from this right-click menu you can select Snapshots and take snapshot. And there's one more button which says Manage Snapshots, which opens up the Snapshot Manager. And this is where you have an option to see which snapshots you have and either delete them or go back to the snapshots. And as you can see right now, it says you are here and it just tells me my machine name, which means I'm on a base state of the machine. There are no snapshots present. If I would make them, they would appear as a drop-down tree. So before we start doing the snapshot, let's take a look at the virtual machine files to understand what's happening when we take a snapshot. So I will go to my data store and I'll check it and I'll show you which files do I have. So I found data store with my machine. It is here. And if you look at the files, we can see the same files we mentioned last time. So there is VMware log. The machine was running, so it made a log file. There is VMX, which is configuration, VMDK, which is a disk, and VRAM, which is memory. And then some extra files which we don't care about that much, right? When we take a snapshot, something interesting will happen with VMDK file, with the virtual disk, because this will be the disk which we are snapshotting. And if you recall from the previous video, if the file would be added to the machine as independent virtual disk, we would be unable to snapshot it. But because it is dependent, we can snapshot it. Just to remind you, if we go to the VM settings and check the disk type, it says disk mode dependent. So this is what allows us to snapshot this VMDK file. So I'm going to take a snapshot now, and we'll check what's happening with the disk after we take the snapshot. So let me show you which options of snapshotting do we have. I click machine with the right mouse button, select snapshots, take snapshot. Now I can name the snapshot. It even shows me the time which I clicked, but it's obviously not right because while we are talking, the time goes on. I'll just call it test snapshot 1. And there are a few options which are now grayed out. There is an option to snapshot virtual machine memory, which makes sense if the machine is running, because then if you roll back a snapshot, the RAM will be in the exactly same state. So all the applications will be running in the same state as they used to run, right? And there is another option called QoS guest file system, and that one is important for transaction-heavy applications like SQL database, Exchange server, domain controller, because that second option triggers in guest volume shadow copy or VSS operation, which is a part of standard Windows backup operation, which prepares applications which are configured for so-called application-aware processing. So if you enable this option, it's going to freeze the system during the snapshot, and the restored disk will be consistent, which means that you'll likely restore useful data. If you do not use this option, the state of the disk will be like there was abrupt power failure. So you will not necessarily get a database which has everything clean. Maybe there was a transaction like writing operation going on, and you stop activity and you switch to the snapshot, and you will lose data after restore. So this is a good option if you want to take a snapshot of a server which has applications which are critical for you and which have support for QoSing or Microsoft Volume Shadow Copy. This option also works for Linux machines, but obviously Linux doesn't have Microsoft technology to freeze applications, and then it needs special scripts which you can prepare. For example, a script which would shut down the database before you take a snapshot, so the database wouldn't be running in the state of some inconsistency. So that's all you need to know. Name the snapshot. I'm not using extra options, but you can. And we click OK. And now the snapshots will be taken. So if you go to the snapshot manager, you'll see that there is a test snapshot, and now we are here. And we have two options. We have an option to go back. You can revert to your snapshot, so you need to select the snapshot and click revert to, or you can delete the snapshot. So there is a huge difference between deleting the snapshot and reverting to the snapshot. So what is the difference? If you were to delete the snapshot, it would mean that you no longer need to have a possibility to go back. So nothing would happen to your data, but you'd be unable to restore anymore. If you revert to snapshot, you immediately lose all the progress you have done since you have taken the snapshot. So on the data store, the new 001 file, which was created as you took the snapshot, which would contain the changes you do to the machine, would be wiped clean to 0 bytes. So you would only want to revert to the snapshot if you are sure that you don't need anything done after the snapshot. And if you don't need to restore, then you would delete the snapshot. So this is a very clear definition and difference which you need to understand so you wouldn't lose data by mistake. Again, If you have made a snapshot and you have done something and you are satisfied with the result, you delete the snapshot, so you don't go back anymore. If you have done something and you are not satisfied with the result and you want to go back, then you do revert and you lose your actions after you took the snapshot. So let me show you what happens once we take the snapshot. We are going to go back to the datastore browser and check it. So we used to have one VMDK file, which was our disk for the machine. However, if you look now, you'll notice that there are two VMDK files. There is old VMDK and now the one which has 00001 suffix added to it. So this suffix means that it's a first snapshot. Well, it's just a naming convention. So if you make more snapshots, they will start getting next number in the queue. So it will be 002, 003, etc. It doesn't necessarily mean that the snapshots are in order, because the snapshots can be a tree. Let me show you this. So for example, if I go back to my machine and I take another snapshot, take snapshot, right? So this will be test snapshot and I'll call it 2. Now let's look at the snapshot manager. Now we see that there are two snapshots, but we can revert to the previous snapshot without deleting the next one. And now that we are in the previous snapshot, so we are not on the snapshot 2, we are in snapshot 1, I can go ahead and take another snapshot. Take snapshot, and this will be test snapshot number 3. So this is the tree I was talking about. We have created variable futures for this machine. So we can have different states which are parallel. So if we go back to snapshot manager, now you see we have two snapshots which are both under snapshot 1. So it means that we have one possibility of, let's say, consequences of data. Snapshot 1, snapshot 2, or snapshot 1, snapshot 3. So 3 doesn't necessarily follow 2. The relationship is described as parent-child relationship. So the snapshot which is under another snapshot is a child of a snapshot. And the snapshot which is above snapshots is the parent. So the only way to see who is the parent, who is the child, is to look in the snapshot manager. And another opportunity is to look at the file called VMSD, VM snapshot descriptor. So to understand how the parent-child relationship works and what is the purpose of the standard disk that you have and 001 VMDK that appears, let's switch back to the simple scenario. Let's say we have one snapshot. So now I'm going to show you the file on the data store again, and we'll check the file size of the new VMDK which appeared. And we'll clear up the naming conventions here. So we can see that there are two VMDK files, and there is one which is 10 gigabytes, which is my system disk, and there is another which is only 1 megabyte in size, and it doesn't change. So you may ask, how is it possible to store the whole state of the disk without consuming extra space? Well, the technology here is called copy on write. So when you would want to write to the disk, normal VMDK file, instead, the new data starts going to 001 VMDK. So 0001 VMDK will only contain the changes you have done to the machine after you have taken the snapshot. And this is why this file is called delta file. Delta means difference. So you have a base file or the snapshot file, which is your main VMDK, which you used to have always, which used to be changing. Now it's no longer changing, and all the changes are going to the VMDK disk, which is named with the number 001. So if you power on the machine, this file starts growing. Let me actually show you this. So let's go back and start up the machine. Power on. And as soon as we do it, we should be able to observe the growth of the new file, which will contain the changes which are done by boot process. So the process boots, it modifies the disk. And now if you look at the virtual disk, you'll see, let me just expand it. Now it's already 40 megabytes. And if you refresh it, Let's see how big it is. Well, I'll have to go back because I pressed F5. Now this is already 77 megabytes, and it will keep growing. And it will keep growing until it reaches the full size of the disk, which means that everything has changed, which is unlikely. It's unlikely that you're going to change everything on your disk, but it will keep taking extra space. So at first, snapshots are harmless, but the longer it takes, the bigger they become. This is why you need to observe the disk space. So what is this copy and write technology? As you remember, I mentioned that differential or delta disks in a chain are children to the parent disk. So the parent disk is the disk that you used to have, which is your virtual disk. And the new children you create are only going to store blocks which are changed by running machine, which means that they all depend on each other. And if there is a block which is not present in the child, it will go to the parent to look for the block until it reaches the parent disk. So this is why the snapshots actually affect performance of the machine, because instead of working with one file, your machine has to work with multiple files. And the longer is your snapshot chain, which is the longest it can be is 30, but I would say it is a bit of a stretch if you would really want to work with such a long snapshot chain. But basically, the more snapshots you have, the more files on the disk, on the physical disk, your machine process has to read and write, and which means that it will affect the performance. And finally, I would like to explain the process of creating the snapshot, deleting the snapshot, and reverting to snapshot using the concepts from the previous video about blocks, clusters, etc. So the snapshot in VMware, the empty delta file as well, they use the concept of grain size. So a bunch of blocks which will be written and read at once. In case of snapshots, usually it's 64 kilobytes. So let's say you have your parent original flat disk. Flat is a disk with data which is part of your VMDK, as we discussed in the video about VMware introduction. So there is also a descriptor somewhere, but your data is in this VMDK file. When you snapshot the machine, it's going to freeze this disk first. So it's not going to change. And then it's going to generate a delta disk for you. And this will be an empty, sparse file without any contents. As you start running the machine, the changes appear. And these changes will be written as these grains into the delta file. So if you look at this situation from the guest, it will perceive this as a whole hard disk with old and new blocks. But in reality, the process of VMware machine would read from two files, from delta file to capture the new blocks and to write new blocks, and from the old file to retrieve blocks which are not present in the delta file. So when you would go ahead and delete the snapshot, on the actual data store, the following will happen. The delta file would simply go ahead and combine with the file that you have of your original disk. This is called consolidation. So two files will be consolidated into one, which means new blocks will overwrite old blocks. And if you were to revert to the snapshot, you would delete completely the delta file, so it will be gone for good. And you would unfreeze the disk and continue working with it. So this is why you lose changes if you revert the snapshot, because you simply discard the new changes. And if you delete the snapshot, you consolidate them into one and you keep working. And of course, if you have a snapshot tree, you'll have multiple delta files appearing on your disk. I will make a separate video on the cleanup and manual fixing of the machine with corrupted snapshots. Otherwise, that should be all you need to know for this part of the training. If you have any questions you would like to ask, go ahead. I'll be welcoming any comments, and I wish you a great day.